Hi, my name is Eric Johnson. I am a Senior Developer Advocate for Serverless at AWS. This video is the fifth installment of a series designed to help you build serverless applications using the AWS Serverless Application Model, also known as AWS SAM. In this video, I demonstrate deploying serverless applications using the SAM deploy command. Whether you're deploying to a test environment from your desktop or deploying to production with the CI/CD pipeline, using SAM deploy can simplify the process. The SAM deploy command manages the process of uploading artifacts and invoking AWS Cloudformation to create or update your serverless application. How SAM accomplishes this task depends on how you're packaging your Lambda function. When using zip archive images, the following steps occur. Step 1. SAM zips all the artifacts for each Lambda function declared in the template. Step 2. SAM uploads the zip archive to an Amazon S3 bucket. By default, SAM manages this bucket per region, and all SAM applications in the same region use the same bucket. It is possible to use a different bucket by adding the S3 bucket flag with a different bucket name. The bucket must be in the same region, and your credentials must have access to read and write to the bucket. Step 3. SAM updates the template with the location of the archive in the S3 bucket. Step 4. SAM calls AWS Cloudformation to deploy the application. SAM breaks this into two actions. First, a change set is created, validated, and compared against any existing infrastructure. If the change set is valid and changes are required, SAM implements the change set using AWS Cloudformation. Step 5. Cloudformation creates or updates your serverless application according to the change set. If your application uses AWS Lambda functions, Cloudformation uses the zip image in the S3 bucket to create the Lambda function. When using container image support for AWS Lambda, the process only differs in handling the artifacts. The process is as follows. Step 1. The local container image is tagged and uploaded to a repository in the Amazon Elastic Container Registry, also known as ECR. Step 2. SAM updates the template with the location of the container image in ECR. Step 3. SAM uses Cloudformation to create or update the application, just like the zip process. Step 4. Cloudformation deploys the application and configures any Lambda functions to use the appropriate container image. SAM is also smart enough to combine the two processes to use both packaging options in a single application template. Okay, let's jump to the terminal and see it in action. For this example, I'm using the AWS Quick Start template for a web backend. This template contains 3 zip archive Lambda functions and an Amazon DynamoDB table for data storage. Since this is the first time I have deployed this application, I use the SAM deploy command's guided option. Running the SAM deploy command, I add the guided or -G flag. Using an interactive prompt, SAM requires some information from me about this deployment. First, I need to tell SAM the name of my stack, which Cloudformation will use. I will call this demo zip app. Next, SAM wants to know which region to deploy the application. I stick with my profile default of US West 1. Now I am asked if I want to confirm any changes before deployment. In the deployment steps, I explained that SAM first creates a change set in Cloudformation, then validates and verifies any changes. SAM can pause the deployment and require manual approval before implementing the change set. While I generally choose no, I choose yes for demonstration purposes. Next, SAM needs permission to create any roles required by this stack for deployment. SAM also makes roles for any event source declared in the template, which gives the event source, for example API Gateway, permission to invoke the Lambda function. If I say no here, the process exits. I take the default yes. The next 3 steps are a warning from SAM informing me that these 3 Lambda functions are unprotected. At the moment, I'm okay with open routes and choose yes for each. SAM then asks me if I want to save these choices in a configuration file. I do not want to enter this information every time I deploy, so I choose yes. I then select the default name for my configuration file to be samconfig.toml. In the final step, SAM asks me to select the deployment environment. There are many strategies to using the profile in the samconfig file. My approach is to use my testing environment as the default profile. This choice means that if I forget to declare a deployment environment on a subsequent deploy, it will deploy to the default. This choice also means that I do not accidentally deploy test code to a production environment. I choose default. SAM now jumps into action. The zip file is uploaded, the template is updated, and SAM creates a change set. As requested, SAM asks me to verify the change set. I like what I see and choose yes to continue the deployment. SAM then implements the change set to deploy the application to my preferred environment. Before moving on, let's take a look at the generated samconfig.toml file. SAM creates a default profile and saved all the parameter values for the deploy command. Therefore, the next time I deploy, I can use SAM deploy without the guided option, and SAM will use these values. In addition to configuration information, SAM can also store application parameters as well. For example, I add a template parameter, test variant, and pass it to the Lambda function to customize the multivariant testing response. At deployment time, SAM expects this value as an input parameter. To test, I run SAM deploy, and I quickly get an error stating that the parameter test variant must have a value. To add these values, I need to run SAM deploy guided process once again. Before continuing, I want to explain the credentials that SAM uses for deployment actions. By default, SAM uses the credentials of the default profile from the AWS CLI configuration. It's also possible to change the account that SAM deploys to using an AWS CLI named profile. For this reason, a good strategy is to set the default profile for development and use name profiles for each environment. For more information on configuring credentials, go to s12d.com/sam-creds. Using this strategy, I can deploy to my staging environment in the dedicated staging account using SAM deploy -g --profile staging. I use the guided deployment because I want to change the region to US West 2, and I want to save it in a new profile called staging in the samconfig file. Once the deployment is complete, I open the samconfig file and I see the new staging profile created with the updated region and updated bucket for that region. I also see that SAM has saved the proper AWS credentials profile as well. With both profiles in place, I am now able to easily deploy changes to either environment. To demonstrate deploying to both environments, I update the timeout for the getAllItems function to 300 seconds. I then deploy to my development environment to make sure that there are no adverse effects from the change. To do this, I run SAM deploy. Because I do not pass any other flags, SAM uses the default samconfig profile and deploys using my default AWS credentials. Once the deployment is complete and I have tested the changes, I can now deploy to the staging environment with the command SAM deploy config-env staging. The config-env tells SAM to use the staging profile for deployment to the staging environment. So far, I have shown the flexibility of SAM deploy using zip archive Lambda functions. The same flexibility applies to Lambda functions that use container images for packaging, though there is a difference that I'd like to point out. First, unlike the zip format, you must use SAM build to prepare your code before testing or deployment. Even with non-compiled runtimes and container image-based Lambda functions, SAM build creates or updates the local container image that will be used for deployment. The second difference is that SAM will ask you to provide an ECR repository for the Lambda function or functions. To show this, I convert the original application to use container images for each of the 3 Lambda functions and run SAM deploy guided. Like zip archive images, I name the stack and choose a region. However, unlike the zip archive images, I am asked to provide the ECR repository for the Lambda functions. I can provide a separate repository for each function, or I can use the same repository across all functions. The best practice is to use a separate repository for each. The rest of the prompts are the same as the zip archive application. SAM uploads the local container images to their respective ECR repositories, creates the Cloudformation change set, and runs the change set to deploy the application. Now that we have deployed this application multiple times, let's take a look to see if it worked. Using Postman, I create a post request with a body containing an ID and a name. I submit the request and get a response with a status code of 200. I can then use a GET request to the same endpoint, and I can see a list of entries, including the one I just submitted. Finally, I send another GET request to the same endpoint, but add an ID to the path. The backend returns a response with my original record in it. See, this stuff works. This has been an overview of the SAM build command. In this session, I covered how SAM handles the upload and deployment of serverless applications. I talked through the difference between a zip archive and container image-based deployment. I also covered using the SAM config profiles to deploy to different environments. In the next session of this series, I talk through some SAM tips and tricks, and I hope you will join me. For more serverless learning content, also check out serverlessland.com. Until then, thanks for watching. Again, my name is Eric Johnson, and you can find me on Twitter at EDJGeek. Have a great day, and remember, serverless for everyone.